Hello students, welcome to this next lecture of the chapter 2, that is lathe machine. Now in this lecture we will discuss about different work holding devices. So first of all, let us understand what are the work holding, work supporting and work driving devices. So the devices which will be helpful to hold the workpiece or to drive the workpiece or to support the workpiece during machining operation, that all devices are called as the work holding devices. So based on the shape and size of the workpiece, there are many different types of work holding devices are available. So this is the list of the different types of work holding devices available. So from all these work holding devices, we will understand the use of each and every work holding device. So the starting with first one, that is the lathe center. So up to now in many of the lectures we have discussed about the different types of center, or we have named that center, that is one that is fixed at the headstock, that we have called it as live center, and the another one that is fixed at the tailstock, that is named as the dead center. So the lathe center can be seen like this. So these are the different shapes. This is the end portion which is fixed inside headstock or tailstock, and this tip type portion is helpful to provide support to the rotating workpieces. So if I say in the case of centers, what happens, one of the lathe center is fixed inside the headstock and the another one that is fixed inside the tailstock. And now both these centers are fixed in headstock and tailstock because these are helpful to hold or support the longer workpieces during machining operation. So these centers are helpful to provide a support to the longer workpieces during machining operations. Now at the headstock portion, the center available is called as the live center. Why? Because this center is rotating as it is fixed in the spindle, and the center available at the end of the tailstock, that center is called as the dead center. And the name given dead center is because at this particular location the center available is fixed in the tailstock and there is no movement of this center. So that is how the name is given to these all types of center. One of the name is live center and the another name, that is the dead center. So some of the pictorial figures of the centers are the another one that you can see, and over here in this figure this center is fixed inside the headstock spindle, that you can see very easily. Now the next one, that is the live center or revolving center, and this center is fixed in the headstock as the rotation is transferred from spindle to the center and from center to the workpiece. So this is the basic use of the lathe center. Now the another work holding device, that is the chuck, and this particular work holding device that is also fixed in the spindle. Now on the spindle rod this chuck is fixed, and this chuck is helpful to hold and support the workpiece during machining operation. And in any of the machining operation, chuck is fixed at the headstock position. Chuck is available at the location of headstock. It is never fixed inside the tailstock portion. So to keep this particular notation in mind. Now let us look at the different types of chucks available for holding the workpiece. So this is the first one, and this chuck is called as the 3-jaw chuck. Why? Because as you can see, this is the hollow portion which is fixed inside the spindle, and that is how its end portion is fixed inside the spindle and it is located over the headstock. Now here there are 3 grippers are provided, and these 3 grippers are helpful for fixing the workpiece between this particular center. Now here one thing is important to understand, and that is when the key is fixed at a particular location and the rotation is given, at that time all these 3 jaws are moving simultaneously. Or we can say that all these three jaws moves with one another, that when the rotation is given or the key is rotated, at that time all these three jaws comes backward together, and similarly when key is fixed, at that time all these three jaws come inside together, means the movement of all these three jaws is dependent on each other. So due to the dependency of these three jaws and these three jaws are moving together, so the centering of workpiece is very easy in the case of the three jaw chuck. So here you can see that this particular three jaw chuck is helpful to hold circular and hexagonal workpiece. So round and hexagonal workpiece can be fixed very easily in this three jaw chuck. The next one is, as the movement of these three jaws is together, the centering is very easy. That's why the process of fixing the workpiece is quick and accurate. And as we have discussed, all these jaws moves simultaneously when adjusted by the keys. Now the another one, that is the four jaw chuck. Now you can see that why the name is given, that is here four jaws are fixed, 1, 2, 3 and 4, and these four jaws moves in this particular four jaw chuck independently, means each and every jaws needs to be adjusted by its particular key during the fixing of the workpiece. And the another thing that you can see is, in three jaw chuck all the three jaws are situated at the angle of 120 degree. So the jaws are adjusted such that the angle between two jaws, that is the 120 degree. And similarly in the case of four jaw chuck, you can see very easily all the four jaws are adjusted such that the angle between the any two jaws, that is 90 degree. So this is the basic difference between three jaw chuck and the four jaw chuck. Now as we have discussed, all the four jaws moves independently. That means any irregular shape and size component can be fixed in four jaw chuck very easily. But here the centering of the workpiece is somewhat difficult, and that requires the accuracy or the precision by the person who is fixing the workpiece inside this four jaw chuck. So now some of the important parameters, that is, first it is helpful to fix the workpiece that are irregular in shape. Now the second one, that is, each jaws can be adjusted independently. And another important thing is that all these jaws can be removed and fixed in the reverse direction to hold the workpiece from the inside diameter. So these are the main important points that you need to understand in the case of three jaw chuck and the four jaw chuck. And all these jaws can be useful for the smaller workpieces also and for the larger workpieces also, which can be easily fixed inside these chucks. Now the next chuck, that is the collet chuck. And the figure of collet chuck you can see easily in this pictorial representation, and you can see that there are the different diameter of holes are available, and these holes are fixed for a particular collet chuck, and these all are chucks are called as the collet chuck. And now based on the available diameter of the workpiece, this type of the different collet chucks are used. So this collet chuck is used to hold the smaller workpieces, and these are useful or required when the precision and accuracy in smaller workpieces work is required. So other than these, many different types of chucks are also available. It may be a magnetic chuck, it may be a hydraulic chuck. So there are different variations of chucks are available based on the components to be fixed or machined in the machining operation. Now the next work holding device, that is the lathe dog or carrier. So during some of the machining processes, it is possible that the workpiece is fixed between the centers, and that workpiece is not directly fixed inside the spindle or chuck. So at that time, to provide the motion or transmit the motion to the workpiece very easily, this lathe dog or carrier is used. Now the figure of lathe dog or the courier you can see very easily. So this is the basic figure of the lathe dog, and how this lathe dog is used to provide support or to transmit the motion to the workpiece. The fixture for that is shown in this figure. You can see that this is the lathe dog, and this lathe dog is connected to the workpiece by providing connection with the spindle externally. So again, this lathe dog is a device that clamps the around workpiece and allows the rotary motion of the workpiece or the rotary motion of the spindle to transfer to the workpiece. Now you can see easily that as the spindle is rotating, it transfers the rotary motion to the available workpiece, as this is the workpiece. Now another one, that is the courier. It is most oftenly used when turning between centers on a lathe. That you can see over here, the center is provided and another center is also provided, and between these two centers, when the workpiece is fixed, at that time to provide the rotary motion, this lathe dog or carrier is connected. So that is how to transmit the rotary motion from the spindle to the workpiece. This type of work holding or supporting device is required. Now the next one, that is the face plate. This face plate is nothing but the circular plate which is fixed inside the spindle. Now as you can see, this is the face plate, and over this face plate certain slots are available. And based on the requirement or the arrangement available, using the T slots, very easily irregular shape and size components can be fixed on the face plate. So this face plate is useful for holding the necessary workpieces on the lathe. And as you have said, this is the circular plate which is fixed to the lathe spindle. Now here, these all the components which are fixed on the face plates, that are fixed using the T slots. So T nuts or T slots are available in a particular face plate for fixing purposes. And these are the basic uses of different types of work holding devices. These all devices are useful for holding the workpiece based on the machining operation required. Now the next one, that is the steady rest. Now as you can see in this figure, in some of the cases there might be a possibility that if you see, if this is the one center available at the headstock, and between two different centers situated at headstock and tailstock, longer workpiece is fixed. Now there is a possibility that due to the weight of this particular component during the rotation, the weight acts downward due to the gravity, and due to which there are chances of the buckling or bending of the workpiece. So to prevent the bending of the workpiece during machining operation for the longer workpieces, this steady rest is used. So this steady rest is fixed at the center position or at the in between position between these two centers to provide the support to these particular rotary workpieces, so that the machining can be performed very easily and longer workpiece do not bend. So you can see the arrangement over here. This is the steady rest, and this steady rest provides the support to this longer bar which needs machining. So this is the workpiece. So I hope you have the idea where this steady rest is useful. So you can take the important points from the notation given over here. So now the another one, that is the follower rest. Now for the follower rest, you can see the figure over here. Now the construction is somewhat similar to that of the steady rest, but in this follower rest, one of the side is open to provide support to the workpiece during machining operation. And in the case of follower rest, this follower rest is fixed over the saddle, whereas the steady rest is fixed on the bed. So this is the basic difference where this follower rest and the steady rest are fixed. And this follower rest travels with the carriage to prevent the work from spinning up and to take away from the cutting tool. That means to maintain the position with the cutting tool of the workpiece, this follower rest provides the support, and as the cutting tool moves, this follower rest also moves with the saddle to provide a support during machining operation. So this is the basic use of supporting the workpiece during machining operation using the follower rest. Now the next one, that is the mandrel. Up to now we have discussed about the machining of different workpieces which are solid in nature. That means solid workpieces can be machined very easily by using different types of the work holding devices. But now when the workpiece is hollow, at that time how one can fix the workpiece during the machining operation. So to fix the hollow workpieces during machining operations, these mandrels are used. And there are many different varieties of mandrels are available based on the hollow shape of the workpiece. So these mandrels are useful to hold the hollow workpieces for machining, which is the important point that you need to keep in mind. And there are different types of mandrels are available based on the requirement. That may be the plain mandrel, expanding mandrel, gang mandrel, and stub mandrel. So based on the requirement, different types of mandrels are used in the market for machining of the different shape and size of hollow workpieces. So in this lecture, we have discussed about the different types of work holding and supporting devices which are helpful for machining very easily and to carry out precise and accurate operation. And we have also noted that based on the shape and size of the workpiece, different types of work holding devices are required. So I hope that you got the clarity about different types of work holding devices which are used in lathe machine for machining purpose. So looking forward to see you all in our next lecture. Up to then, thank you.